Let's have a look what can happen inside a blood vessel. If the bloodstream slows down or stasis happens, platelets may settle down on the vessel wall and a process may be started which in the end might lead to the forming of a thrombus. The process involved in thrombus generation is the coagulation cascade, an important mechanism to stop, for example, blood loss after a vessel injury. There are two pathways involved in thrombus generation, named the intrinsic and extrinsic pathways. Both pathways lead to the same fundamental reactions that produce fibrin. Let's have a look at the following on how fibrin is generated. A crucial point in the coagulation cascade is when both pathways meet. It results in activation of factor 10 into factor 10A. Let's see how this happens. As a start point, factor 10A forms a complex together with factor 5A. It is called prothrombinase complex. As a serine protease, this complex cleaves prothrombin so that thrombin is produced. Thrombin in turn activates fibrinogen into fibrin, a molecule that has the ability to polymerize and form a network. Other blood components such as platelets and red blood cells are then trapped in the forming fibrin network. A thrombus starts to grow. This event can lead to a life-threatening event if critical vessels, like for instance coronary arteries, are affected and blocked by the clot. Sometimes the formed thrombus can detach from the vessel wall, be carried away by the bloodstream, and cause serious events like a pulmonary embolism or a stroke. How can this process be prevented or stopped? Arixtra is a synthetic anticoagulant consisting of 5 saccharide units with sulfate groups strategically positioned. Arixtra is shown here as a blue molecule. It binds strongly and exclusively to antithrombin, the primary endogenous regulator of blood coagulation. Arixtra modifies the conformation of the antithrombin molecule. By selectively binding to antithrombin 3, Arixtra potentiates the neutralization of factor 10A by approximately 300 times. Let's have a closer look at how this happens. When the antithrombin 3 fondaparinux complex enters a factor 10A molecule, the factor gets trapped in the active site of AT3 and can't exert its activity. As a consequence, thrombin generation is inhibited. Arixtra is then released and made available to bind to other antithrombin molecules. Both the lack of thrombin and fibrin generation prevents the formation of blood clots in the vessels. Furthermore, the perpetuation of blood clots is a dynamic process. The reduction of fibrin supply shifts the equilibrium towards lysis so that existing blood clots dissolve. The blood can flow again freely. So, now you understand how the anticoagulation cascade works, and where Arixtra as a selective indirect anticoagulant acts to prevent clot generation or breaks down thrombi. We have briefly reviewed the coagulation cascade and have shown how Arixtra, a selective anti-10A inhibitor, helps prevent clot generation or disrupts downformed thrombi.